A cornerstone of today's microservice-based architectures is the incorporation of web-based APIs. Now, the term web API, it's a bit overloaded and can include a range of protocols like gRCP, RSocket, and GraphQL, just to name a few. So for the purposes of our discussion, we'll confine the definition of web APIs to arguably the most common implementation, which are RESTful APIs. RESTful APIs are generally implemented as HTTP endpoints consisting of structured payloads using something like XML or even more commonly using JSON. So web APIs, we can view them from two perspectives. The first is the server perspective, which hosts the APIs and its implementation. And then the other is the client or the consumer perspective, which makes API calls over HTTP over to the server. So it's easy to think of a web API as a public-facing contract of your application's business logic, but they're not necessarily limited to only doing public-facing endpoints. In applications consisting of multiple microservices, web APIs are also a common method to make internal service-to-service calls. In the Where for Dinner app, we have both public-facing and internal web APIs, and this app uses both API, server, and client constructs. And of course, Spring has excellent libraries that help us implement both of these perspectives, allowing us to spend a lot more time doing all the important stuff. So we're going to look at the abstractions that Spring provides us for implementing both web API servers and clients. So let's jump first into looking at the server side of things, which is implemented by a module called Spring Web. And we're going to start off from scratch here with a very trivial sample, and then we'll go and look into the Where for Dinner APIs. So let's create a new Spring project using the Spring initializer inside of VS Code. And we'll go ahead and start here. We're going to start off with creating a Maven project. Then we'll go ahead and use the latest release of Spring that's available to us as of today. This is going to be a Java app. A com.example, that's fine as our base package. Then we're going to go ahead and name our project to Hello Demo. We can package this as a jar. It's not going to be a war. And then Java 17 is going to be fine for our purposes. And next, now we need to pick some frameworks for our app. And we'll just choose the Spring Web app because that's all we're really going to need for this demo. Then I'm also going to choose developer tools so I can have some live reloading as I code. So we'll go ahead and save that on my workstation. And then we'll open up our new project. Okay, so now we have the bare minimum scaffolding for a Spring Boot app, which is just the main application class. But we also have all the other Spring libraries that we need on our class path. So next, let's go ahead and create a very simple web endpoint using a framework called Spring MVC, which stands for Model View Controller. You're probably familiar with the MVC paradigm. There are other ways to create web endpoints, but personally I think Spring MVC, it's one of the easiest ways to do it, and especially for APIs that really aren't all that complicated. So let's create a new class for our API endpoint. I'm just going to call it Hello API. So now I've got an empty class. And the first thing we need to do is add the REST controller annotation, which is one of those annotations that Spring's going to end up looking for at startup time. And it's going to recognize this class as actually being a controller for our web API. And then it's automatically going to manage its lifecycle for us. So next we'll add the request mapping annotation. This is where we can define the relative URI for our API. And we'll just call it v1/hello. So now we're ready to start adding some operations to our API. And we're going to create a very simple one, and we'll just call it say hello. And all it's going to do is just simply just return back the string hello. Not very overly complicated. So now we have to tell Spring that this method, this say hello method, it's part of our API, and that we're going to access it using the get verb. So in order to do that, we just annotate it with the get mapping annotation. And that's it. So at this point, we're ready to go ahead and try out our new application. So we're just going to test it out here and run it. And then we're going to use the command line, a nice little tool, HTTP Pi. And we'll test it out by doing HTTP and then localhost 8080 v1/hello and let that run. And here we can see that it returns back HTTP status 200 with a payload of hello. We can also see that the content type is listed as application JSON, but it's actually kind of hard to discern that just from seeing a simple string. So to demonstrate this a little better, let's go ahead and create something that returns a list of strings, and then we're going to go look at the output. So we're going to create a new method, and we'll just call this one say hellos. That's going to return a list of strings. And we'll just have it return hello 3 times in a list. And then we're also going to need to add a get mapping for this. So this time we'll add it on here, and we'll just give it a subpath of hellos. It needs to distinguish itself from our other API. All right, so we'll save this and let DevTools reload the app. So then let's call our API again from the command line. It's HTTP, again, localhost 8080/v1/hello. And now we'll add on /hellos. And now this time we can see that we've got a JSON array of strings that gets returned. So looking at this, we might infer that Spring has the ability to convert pretty much any type into JSON and vice versa. And it turns out that's pretty much the case. Internally, Spring registers converter classes that can handle very simple primitives like string and ints to very complex data structures. And if you happen to come across a structure or a class that can't be handled out of the box, it is pretty easy to create and register your own converters. So anyway, this illustrates just how easy it is to create a functioning web API with very, very little code. Again, this is an extremely trivial example, and in many cases, the API code would generally delegate to something like a business logic layer. So let's actually go look at that. Let's go look over at one of the methods now over in the Where for Dinner app. We're going to look at the search API. And as we look in the code, we can see it's implemented in a class called search resource. And it's worth noting in REST APIs, we sometimes call our API endpoints or the RESTful resources. So when I write these APIs, I like to postfix all my classes with the name or with the term resource. So anyway, we can see that this class has the REST controller and the REST mapping annotation with the relative URI of this API. And because the business logic in Where for Dinner, it's not really overly complex. It's actually pretty straightforward. I made the design decision to go ahead and just implement the business logic directly in the API methods. That's versus creating like business logic interfaces and implementation classes. So the business logic mainly just makes a call to the data layer. And if you remember in our previous video that our entire data layer was implemented using Spring Data repositories. So if we look here up here towards the top of the class, you can see here I have Spring injecting that search repository object into my API class. Now let's look at one of the methods in the search API. This one's called getAllSearches. And what this method does, it just returns a list of all the stored searches that are in the system for a particular user. And you probably noticed here this principal object that's getting passed as a parameter. A Spring MVC, it's got a slew of different parameter types that you can add to a web API's method signature. And the principal is just one of those types. So we'll see in a couple minutes where we have a request body also as a method parameter. So if we look at the code of this method, what we do is we extract the request subject out of the user principal, and then we use that to make a call to the database layer to get all the searches for that particular request subject. And then when that gets done, this is either just going to return a list of all the found searches for that user, or it's going to log an error message out, and then it's going to return back an HTTP status of 500. Note that I said it's going to return a list of searches, but actually what it's doing, it's returning a flux of searches. I mentioned in our previous video that our data layer is reactive, so it makes sense to also make the web layer reactive. These just are an optimal combination to put together. So this gives our application a lot of advantages in terms of resource usage. All the web API invocations, they're capable of being non-blocking since they are returning the reactive constructs of either Flux or Mono. And then that means that the underlying web infrastructure doesn't necessarily have to create a thread for each one of our API calls. And in fact, it only creates just a very small number of threads for every single API call. So because most of the business logic, it's all ingrained in these non-blocking database IO operations, it's a lot more efficient for the framework to just reuse the same thread to go doing other things like handling another API call, while our current API call, it's just waiting there for data to be retrieved from the database. So our thread can go off and do other things instead of having to create more threads. Now, in order to use the reactive web APIs, we need to use a slightly different set of Spring Web libraries. So instead of using the dependency of Spring Boot Starter Web, which is what we had back in our trivial sample, we ended up using a library called Spring Boot Starter WebFlux. And it's worth mentioning that using WebFlux, it's got a few other side effects other than just enabling the use of reactive programming. First, WebFlux applications, they end up using the Netty web server by default instead of using the Tomcat web server, which is what you get if you just use Spring Boot Starter Web. There's also some other configuration implications. For example, WebFlux applications don't use servlet filters like Tomcat apps would. There's also some security configuration implications. But actually, both of these topics, they're kind of out of scope of this video, but this is just something to keep in mind. So let's look at one more of the methods in the search API, and that's the add search method. So looking at the annotation, you can see here instead of using the get verb, this is actually the put verb. And then we specify that it is consuming a JSON. Application JSON is the content type. And then there's also a new annotation here called response status. And what that does is that's going to indicate the default HTTP status code that we want it to return when our method finishes successfully. And in this case, since we're actually creating new resources, it makes sense to return the status of HTTP 201, which is means created. And then lastly here, if we look at the message, or we look at the method signature, you'll also notice that there's this request body annotation, which indicates that this particular parameter is actually representing the data in the HTTP request body. So Spring, what it's going to do is use one of the pre-installed converters, and it's going to deserialize that JSON payload actually into our search object. And then at the end of this method, the return value, it's just going to end up being a mono of the search object that we create and that we saved in the database. So this gives you just a little bit of taste of what you can do on the server side of creating web APIs. I'm going to defer over to the Spring Web's online documentation to outline all the other really cool things that you can end up doing with an API server. The search API, it's one of the application's public-facing APIs, so it generally gets consumed either by an external system or, in this case, a Where for Dinner. It's used by the web UI. And the web UI in Where for Dinner, it's actually written in React.js, and React.js, that's an interesting topic in and amongst itself, but it's actually out of scope for our Spring discussion. However, there is a service in here, the crawler service, which implements a web API that only gets used internally. And specifically, it gets used from the search processor service. So now we've got this use case where one of our internal services needs to call another one of our internal services. So with this use case, this is where we're going to look at how to write a web API client using Spring. So I want to give you just a little bit of history here of web API clients. So over the years, there's been several different Java libraries that have become available to execute HTTP transactions. And unfortunately, a lot of them really require developers to write a bunch of boilerplate type code that doesn't really add a lot of value. It's just very generic stuff. So fortunately, Spring provides us with some very easy to use solutions that can abstract you away from all those nasty underlying details. One of the earlier solutions, and this is actually still a very popular construct today, even though its use has been somewhat discouraged in favor of new solutions, and this is called REST template. So REST template, it provides a very robust but pretty highly or high level API for executing all sorts of RESTful variations without having to expose developers to the nasty HTTP level code. So in Spring Framework 5, which aligned with Spring Boot 2, there was a newer client that was released, and this one was called Web Client, and it had a lot of advantages over REST template. Most notably is that it's actually based on the reactive model, which inherently allows you to support things like functional and composable programming. Both REST template and web clients, these are great REST clients. I love using them. They're really good. However, they're very imperative in their use. And so there's another REST client framework, and this one's called OpenFane. And what it does is it supports a declarative client, which it's very similar in nature to things like Spring Data Repository interfaces, which we covered in our previous video. So what Fane does, it allows you to define a web API client as an interface, and it uses different primitives to define things like URI paths and request bodies and query parameters, and that's just to name a few things. And the Spring Cloud project, it provides a module. It's called Spring Cloud OpenFane. It's no surprise that that's the name of it. And this even allows you to define interfaces using Spring MVC primitives, meaning that they look very, very close to what your web server method signatures look like. So personally for me, for the longest time, OpenFane was my favorite web API client. However, it lacked reactive capabilities. And there is a third-party library that's referenced in the documentation that's out there that does provide reactive capabilities for OpenFame. However, it's not actually officially supported as part of Spring Cloud OpenFame, and I've found that it does have some compatibility issues when it comes to trying to utilize it with new releases of Spring Boot and Spring Cloud. So in Spring 6, there's a new declarative framework that was introduced, which was actually really inspired by projects like OpenFane. And what it is it has declarative features of OpenFane, but it also supports reactive programming. So at one time in Where for Dinner, we actually were using this third-party reactive implementation of OpenFane, but as I said, their compatibility can be problematic as you try to upgrade. So Where for Dinner ended up moving over to the new Spring declarative clients when we moved it over to Spring Boot 3. So let's go ahead and take a peek and see what these new declarative clients will look like and how to use them. So first, let's look at the API of the service that we're going to call. This is going to kind of show you how the interfaces kind of match each other. And we're going to end up calling a service over in the or calling an API over in the crawler service. And we can see here it's called search resource, and this is in the crawler service. And one of the things I want to call out here, I do have these annotations inside here. We didn't cover this in our previous example called request param. On the server side, this is how we can define query parameters that end up getting used in a REST interface. And we can do things like mark them as required, or we can even give them default values. So now if we go back to the search processor service, which is the one that ends up calling the crawler service, I've got this interface here, or declarative interface here called crawler client, and that contains a method for each one of the API endpoints that we're going to end up calling in the crawler service, which is just one API method. The search method, that's the one we've got here. It's got this annotation on it called getExchange. And that includes the relative URI of the API endpoint. And then we look at the method signature here. You're going to notice it looked almost exactly like the one that we saw over in the crawler service. We've got the request param annotations, and like I said, it looks very, very similar. And also notice that it also returns a flux, which means it's reactive. Now, this is the place where I think OpenFame has a big differentiator, a better differentiator over Spring declarative clients, at least for now. With Fane, you can provide an additional annotation on the top of the interface, along with like the target service name or the URL of the target service. And what will happen is Spring auto configuration, it's automatically going to detect this interface, and it creates an interface or creates an instance of that client for you, and then manages its entire lifecycle. With Spring declarative clients, we don't have that capability yet. You actually have to provide some configuration itself. And I'm hoping sometime in the future that ends up changes and it gets a little more automated. But It is what it is. So let's go take a look at what this looks like. So I have this class here. This is called declarative client config. And in here is a bean creation method called get crawler client. And the first line of this, which you can see it do, is creating a web client using a builder, which ends up containing the service ID or the URL to the crawler service. And then the next line below that, that's creating a factory for our declarative client. And then the last line here is what's actually creating that client instance by the factory. And then this is returned by this bean creation method. So now it's available to be injected into any of our classes where we need it. Again, these steps aren't required with OpenFane, but I am hoping this process gets a little more automated in the future. So now let's go see this client in action. I have this business logic class here called crawler service that implements the searcher interface. And this particular implementation, what it does, it uses the crawler client to call the search crawler service, as opposed to another implementation that just ends up creating a bunch of random search results locally. And you can see here the crawler client, it's getting injected into this class using Spring injection. And then the implementation of this class, all it does, it just calls the search method on the client, and then it just returns the flux, and that's it. Pretty easy. So there's definitely a lot more that we could end up doing with web clients, like providing things like timeouts and retries. But again, I'm just going to defer to online documentation to allow you to discover all the additional things that you can do. Okay, so we've seen web APIs from both the server and consumer perspective and how easy it is to quickly write code for both sides of the fence. We also saw that web APIs work just as well for internal services versus just having public-facing services. And with that said, web APIs, they're not the only way to move data from service to service, particularly inter service to service communication. And in the upcoming video, we're going to look at how to accomplish this utilizing an asynchronous messaging system.